In this short video, we are going to learn how to solve for the equilibrium in a Stackelberg model of oligopoly. Citrus Splash and Tropical Twist compete in the market for fruit-flavored soda. The firms are currently engaged in Stackelberg competition, with Citrus Splash acting as the leader. They face the inverse market demand curve, P equals 50 minus QC minus QT, where QC is Citrus Splash's output and QT is Tropical Twist's output. P is the price per pallet. Each firm produces soda at a constant marginal cost of $20 per pallet, and we're also told that neither firm has any fixed costs. Our goal here is to determine the Stackelberg equilibrium quantities as well as the price in the market. What do we need to know in order to answer this question? We need the market demand curve or inverse demand curve. We need each firm's marginal cost and fixed cost, or information about their total cost curves. And we also need to know which firm is the leader. How do we solve this question? First, we're going to use profit maximization to determine the follower's reaction function. This means we'll set marginal revenue equal to marginal cost and solve. Then we will determine the leader's output by incorporating the reaction function of the follower before the profit maximization process. What does this mean? We'll take the reaction function, we will plug it into inverse demand to find what's called the residual demand curve, and we'll use that residual demand curve to maximize the profit of the leader. Once we have the leader's output, we'll go back to the reaction function to determine the follower's output. And finally, we'll use inverse demand to find the price in the market. Let's solve this question. Here's what we know: inverse demand, marginal cost, no fixed costs, and we also know that Citrus Splash is the leader. With this information, we are going to determine the Stackelberg equilibrium quantities as well as the price. Our first step is to consider the behavior of the follower. That means we need to find Tropical Twist's reaction function by setting marginal revenue equal to marginal cost. We have marginal cost, but we don't have marginal revenue, so we need to find it. So Tropical Twist's total revenue is equal to the inverse demand, 50 minus QC minus QT, all times QT. Dealing with this parenthetical, we get 50 QT minus QC times QT minus QT squared. From here, we can find the marginal revenue for Tropical Twist by finding the partial derivative of the total revenue function with respect to QT. This partial derivative is 50 minus QC minus 2QT. So we have our marginal revenue for our follower now. We are going to take this marginal revenue and set it equal to marginal cost. That's going to allow us to solve for QT. This will not be a numerical answer, but instead it will be a function that tells us how Tropical Twist should respond optimally to the leader's behavior. So filling in what I know, I have 50 minus QC minus 2QT is equal to 20. Solving for QT, I have 2QT on the right-hand side of the equation, and on the left-hand side, 50 minus 20, which is 30, minus QC. Now I'm going to divide both sides by 2, and when I do that, I get that QT is equal to 15 minus QC, we'll say minus 0.5 QC. And that's the reaction function for the follower. Our next step is to find the optimal behavior of Citrus Splash, the leader. How are we going to do that? We need to substitute the reaction function into the inverse demand curve to find the residual demand for the leader, and then have our leader maximize their profit. So I'm going to call this PR for residual inverse demand, and PR is equal to 50 minus QC minus, in place of QT, I put what I know about it, which is that it's 15 minus 0.5 QC. Now be really careful about the negative sign in the parenthetical as you simplify questions like this. We have PR is equal to 50 minus QC minus 15 plus 0.5 QC. Collecting my like terms together, I get that PR is equal to 35 minus, let's see, minus 1 plus a half, so minus 0.5 QC. We can call that equation 2, and that's our residual demand, the demand that's left over for the leader. Now we are going to take this residual demand curve and we're going to use it to compute Citrus Splash's total and marginal revenue. So their total revenue is equal to price of 35 minus 0.5 QC, all times their output of QC. So we have 35 QC minus 0.5 QC squared. Their marginal revenue is just the derivative of total revenue with respect to QC, which in this case will be 35 minus, we bring down the 2 and it turns the 0.5 into a 1, so it's just 35 minus QC. We can call that equation 3. Using this marginal revenue, we should be able to solve for our leader's optimal output by setting marginal revenue equal to marginal cost. So I have 35 minus QC is equal to the marginal cost of 20. Solving this is fairly straightforward. We have QC is equal to 35 minus 20, which we can rewrite as QC is equal to 15. Now that we know the optimal behavior of our leader, Citrus Splash, we can go back to that reaction function to determine the optimal behavior of the follower, Tropical Twist. What do I mean by that? I mean, we're going to take our QC equals 15 and we're going to plug it into the reaction function of the follower to figure out their output. So in this case, QT is equal to 15 minus 1/2 of 15. A half of 15 is 7.5. So QT is equal to 7.5. We can call that equation 5. We have successfully solved for the Stackelberg equilibrium quantities, but we still need to find the price in the market. And we're going to do that by substituting our quantities into the inverse demand. So price is going to be equal to 50 minus 15 minus 7.5. Doing this math gets us the fact that price is equal to $27.50. So we have our final solution. Citrus Splash sells 15 pallets of soda. Tropical Twist sells 7.5 pallets of soda. And the market price is $27.50 per pallet.